Okay guys, you're welcome back to our class again. In this particular experiment, we are going to be presenting to you the electricity demonstration for Wassce 2023 physics exam. And in this particular exam, it is very unique because we have a rheostat, an ammeter, voltmeter, a key, a cell, meter bridge, resistor bus, and then 10 connecting wires. So all we want to achieve in this particular experiment is just to make it simple such that anybody can be able to perform the experiment no matter how the setup comes up. Now, if you look on the screen, you're going to see the diagram that we are using. However, for this particular demonstration, there is no resistance bus. You were told that there is going to be a resistance bus in the question. But for this my experiment, I am not going to be using a resistance bus. But whatever I'm going to do here is going to present a basic idea for your students to excel in conducting this experiment. So this is the components as you see here. The meter bridge is here. Here is the rheostat. Here is the cell. Here is the ammeter. I'm using a 0 to 3 ammeter. None was indicated. And then here I'm also using 0 to 3 voltmeter. And here is my key and then my jockey. So you can see there is no resistance bus in this my setup. Now the idea of using a rheostat is for us to get the maximum current or the minimum current in the circuit. Definitely it's going to be about the maximum current. We are told to use a 2-volt cell, but if you cannot find a 2-volt cell, you can use two 1.5 volts, making it a total of 3-volt cell. So the diagram is on the screen for you. Do well to make the connections the way it is there. And I'm going to also set up the experiment as it is in the diagram there. And then I will show you the procedure that you're going to follow to get the readings that you're expected to get. And then tell you what to plot against what, and then show you the theory and some other short answer questions that may come along this particular experiment. But the summary is that whether there is resistance bus in this particular experiment or not, whatever you're going to practice in this particular experiment will be of an advantage for your students, because it is not necessarily going to be very far away from what you have here in the day of your exam. So stay tuned as I do the connections, and then I'll come back to take the readings. Okay, now taking a look at the drawing and comparing what we have here, you can see that both the 1 ohm resistor that we have here, the voltmeter, and the rheostat are connected to this end of the meter bridge. Check the drawing, you can see that 3 of them are connected or looped together to one end from here. Now let me go through this route. This is the rheostat. The rheostat, the other end is connected in series with the cell, and then the other end is connected in series with the ammeter, and then the ammeter is also connected in series with the key, and then the key with the 2 other ends of the 1 ohm resistor and the voltmeter all joined together and then connected to the jockey. So this is the junction for that particular connection. So we are going to now use the jockey to tap the potentiometer at the given point. So this is exactly what the setup is all about. You can see there are many connections here, but don't be confused. Just follow this circuit diagram and connect it. You would get the correct answer. So let us confirm whether our circuit is actually working. So let's see. You can see that my voltmeter doesn't have 0 error. My ammeter as well doesn't have 0 error. So if I slot in the key and then check, you notice that my voltmeter has deflected and my ammeter has also deflected. So I can regulate this with the rheostat. So I will just simply find the point where I will get the maximum current flowing through the ammeter, and then for the question, and then I'll proceed. So in the question, we're told to find or to adjust the rheostat such that when the jockey is placed at P, the ammeter records the maximum displacement. So the P is just at the zero point, this P here. So if we tap the jockey at P, this is jockey at P, what will be the maximum reading on the ammeter when this is tapped at this point? So this is what we have. Here is the jockey at P, which is at the 0 mark, and then this is our reading. Just 0.951, between 0.95 and 1. For avoid parallax error, that's 0.95. So we can take it as 0. So we're told to record this as IM, which is 0.95 amperes. Well, we're not told to leave this rheostat fixed at this point all through the experiment. So I'm not going to touch this rheostat again to adjust it until the end of the experiment. So I'm not going to, according to the procedure you're looking at there, I'm going to tap the jockey at point S, and S is the length is 15 cm. So I'm going to be tapping it at 15 cm. So now we're set to take our readings. Now, according to the instruction that you see on your screen, we are told to tap the jockey at point 15. And when we do that, we should take the reading on the voltmeter and the ammeter. And then remember that once you finish taking your reading, you have to unplug your key in order to preserve your battery for the experiment, in order not for it to run down. So I'm going to be tapping the jockey at point 15, and then we'll see what our reading is, and then we'll record that. So quickly, what will be the reading at point 15? So let's see what we have. So first of all, I'll close my key. So you can see already it has deflected, but that is not the maximum we can get. So I tap it at 15. I have here to be what? 2.75, and I have here to be what? 0.8. So I'm going to record that and then continue. After this, we are also expected to proceed to the next, which will be at point 20 L. So I am also going to be closing the key for this again, and then tap at 20 quickly. So here I have the V at 0.727 now, and I have this one at 0.7, more than 5. 77, let me say 77 or 78, let's use 8, 0.78. So I'm going to record that quickly, and then we'll proceed again. All right, so we're making progress. Now we are going to proceed to the next length, which is length 30 cm. So I am going to now close the key back again, and then tap the jockey at point 30. Let us see what we have here. We have 0.65, as you see here, and then we have this now completely at the center. That is 0.75. So I'll record that, and then I'll continue. All right, continuing, I'm going to proceed to length for 40 here, and here is 40. So always remember to unplug your key to secure your battery. So I have my key on, and I have the jockey at point 40. Here I have it at 2.6, and then here I have it at 0.7. It's not up to half of it. This is maybe like say 2. I can say 2, 0.72. So I'll record that and then we'll proceed. Okay, so we have two more to go. Now we have at 50 as well, and then at 60. So at 50, I'll close the key and then tap my jockey at point 50. I have this one, the voltmeter here. I have it at 2.6. I think this is still the last reading, and then I have it still at the same position. 0.72. Okay, so I can still maintain this because that's what I have here at 0.50. So that's what reading is giving me. That's electricity for you. So let's record it because that's what we have. Then finally, I have the last 160. Let me put my key on. That is at 0.60, and then here is 0.60. So let me tap the jockey at 60. So here's what I have here. Wow, 2.65 increased. This one also increased 2.75. There's an increment in this one. So let's record what we have. So having completed the experiment, so we are going to compile our table, and this is what the table really looks like, because in that same question they asked us to evaluate the inverse of L and the inverse of the V. So the complete table is here. Remember our initial current at L is equal to 0 is equal to 0.95 amperes recorded on top of the table, and then our L 15 to 60 all captured, the current value, the voltmeter value, and then the inverse of both the L and the V all captured on the table. Recall that for you to compute anything that has to do with reciprocal, logarithm, and all of those, you have to record it on the table to a minimum of 3 decimal place. So, but we are leaving it at 4 to be on the safe side. So having compiled this table, the question says that you should plot a graph of I/O inverse of V, that is 1 over V, against L inverse. And this is what the graph looks like. So you can see that it is a negative graph. So actually a straight line. So when we plug this graph and find the slope for this graph gave us minus 0.417 cm per volt, and the intercept CU on the vertical axis is 0.39. Now there are so many questions they can ask you around here, but I do believe that those ones will not be much of a problem for you. As expected, you'll be asked to state 2 precautions that you took to obtain accurate results for this particular experiment. One of them is that I ensured tight connections. I avoided parallax error in reading of the meter bridge. I avoided 0 error in reading the voltmeter and the ammeter. I avoided scraping the jockey on the wire, and finally I opened the key when not taking the readings. So these are all precautions. You can just select any tool that is convenient for you for this particular experiment. Now we have some other short answer questions that are likely questions for this particular experiment. I'll just run some of them through, and then you can be open-minded because it is not limited to what I have here. It can be broader than this. But this is just a framework for you to have something to work with. Ohm's law, state Ohm's law. Remember that Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided that all physical conditions and temperature remains constant. Now, they can ask you to that if the potential difference across the load in the circuit above is measured, it will be observed that its value is less than the electromotive force of the battery. Explain the reasons for this difference. Of course, the reason is straightforward. This is because when current flows through a battery, there is a potential drop. that takes place across the internal resistance of the battery. So you remember that the equation E is equal to V plus V, that is the terminal velocity plus the lost volts. So if you make V subject formula, you are going to get E minus IR. But just note that it is not always like that. If you're charging the battery, the reverse process is what occurs. So that's the answer to that question. Apart from that, they can ask you to explain what is meant by the potential difference between 2 points in an electric circuit. Now, the potential difference between any 2 points in an electric field is defined as the amount of work done in moving a unit positive charge without acceleration from one point to another along any path between the 2 points. Mention 3 examples of non-ohmic conductors. The examples of non-ohmic conductors are filament lamps, semiconductor devices like diodes, we have transistors, we have thyristors also. And then they can ask you to give 2 examples of using a potentiometer over voltmeter for measuring potential difference. One of them is that voltmeter and potential differences both measure voltage, but potentiometer measures exact value, while the voltmeter measures approximate value. Potentiometer measures exact value, voltmeter measures approximate value. Of course, you know that the voltmeter has a pointer, and sometimes the reading experimental error can occur as a result of reading the pointer. So the potentiometer does not draw any current while measuring the EMF, whereas the voltmeter draws current to measure EMF. A potentiometer works on the no deflection method, whereas a voltmeter works on deflection method, especially for the pointer. A potentiometer has high sensitivity, but a voltmeter has low sensitivity. And then a potentiometer is also used to measure the internal resistance of a cell, whereas a voltmeter cannot be used to measure the internal resistance of a cell. Explain the term electrical resistance. Electrical resistance is a measure of the opposition to current flow in an electrical circuit. Right? It is measured in ohms. State 4 factors in which the resistance of a wire depends on. Number 1, the nature of the material, the length of the conductor, the area of cross-section, and then the resistivity of the material. What is meant by lost volts? The potential difference across the internal resistance of a cell. State 2 effects of electric current and 1 application of it. There are so many effects of electric current. I can choose heating effect of the current and magnetic effect. What are the applications of heating effect? We see this on daily basis, used in the working of appliances like the electric heater, electric kettle. When you plug them to the source of electric current, they are heated up. All right, as current is flowing through the conductor, heat is produced in the process. So that is called the heating effect of current. We also have what we call the magnetic effect of current. This is applied in electromagnets. For example, electric bells, earpiece, the magnetic relays, and so many other devices. Now, in this case, a magnetic field is created as a result of the flow of current. This is seen when you connect a solenoid that is wound around a metallic piece to a cell. When you do that, you can use the metallic piece to pick iron filings to show that a magnetic field has been created in it. So these are all effects of electric current. Apart from this, there are so many other questions, theoretical questions that can come up, and then some of them also could be mathematical questions. Let me just do one of the mathematical questions. A battery of EMF 12 volts and internal resistance 2 ohm is connected to a resistance of 6 ohms. Calculate the terminal potential difference. So you see, I'd already mentioned this formula today. E is equal to I bracket R plus R. Then when you substitute the values, find your I and then refer back to Ohm's law, where V is equal to IR, and you will get your terminal potential difference. So these and many more can be questions that you are going to see in your experiment. Don't forget that the experiment centers on the verification of Ohm's law and then most of the questions are just going to come around the EMF. What is EMF? Define EMF. What define potential difference, and everything that concerns this. So I wish you all the best. I know that this will definitely be of help. You can do well. Please share and subscribe to our channel, and stay tuned for more posts. God bless you.